How would you use data to help Snap engineering measure, evaluate, and improve phone camera speed? Hi everyone, we're so excited to be here today for another Exponent mock interview with Evan. For those of you who don't already know, Exponent helps you get your dream tech job through our online courses, peer-to-peer mock interviewing platform, and interview question database. Check it out at tryexponent.com. Evan, it's so great to have you here today. Thank you for being here. For our viewers, would you give a little introduction of who you are?
Sure thing. Hey, I'm Evan. Super nice to meet you. I worked in data science and data science related things, some research science at Snap for a few years, and then at Uber before that. Currently just taking a break to do some econometric theory and work on my own projects. But I've worked quite a lot in industrial data science.
Well, that's awesome. So it sounds like you've got a lot of job experience. All right, so let's get right into it. So our question today is, how would you use data to help Snap engineering measure, evaluate, and improve phone camera speed? All right, so a little bit more context on this is that Snapchat is a multimedia media messaging mobile application that's used by a ton of users, specifically about 300 million every single day across the world to share pictures and videos, send messages, and other such things. So for continued user engagement, they want to make sure that the mobile application loads and runs quickly on many different types of phones and also in different types of mobile conditions and so forth. So in other words, engineering performance is a really important factor for growing user engagement. So the camera is the main engine of the Snapchat app, and it needs to be really fast. So suppose that the Snap engineering team has asked you to optimize phone camera speed for the first time, and they want you to help them explore that area and justify it to leadership. So specifically, they would want to know, how would you think about the mobile camera speed? How would you measure it? And how would you make a case for optimizing it?
Great. Well, we're starting off with a pretty big question, so let's break it down into the different subsections. The first one is just, how do we think about mobile camera speed, and why would we want to go into this area? Can we think about this like a product manager just a little bit? So let's just start with a high-level business intuition. Why do we care about mobile camera speed? Well, intuitively, as a user of Snapchat, if the camera is too slow, I can't take photos or videos to send it to friends. The camera, when I use it, it may freeze, crash, or not capture the exact moment I want, capture the wrong moments. If my friends and I, of course, we can't send photos to each other at the most basic level, then we'll just stop using Snapchat. And since our engagement goes down, that's going to ripple through the network, and that also means that we generate lower ad revenue for the company. Additionally, if we can't use the camera at a basic level, it also means that we can't even use any more advanced stuff. All the cool stuff Snapchat does, like filters and lenses and all the interesting stuff that keeps me engaged with Snapchat as a product. So from a product point of view, it's very important to safeguard phone camera speed because it's foundational to our whole Snapchat product, and of course, all the revenue that comes from that. So that's the first thing. So again, sort of how do we think about mobile camera speed? The second thing is sort of moving on to the data science part of this. How do we think about measuring mobile camera speed? How do we think about measuring phone speed? So just sort of reviewing a couple good principles for good metrics. A good metric should have some directionality. So if it goes up, that's good. If it goes bad, it's bad. Or if it goes down, it's bad, and sort of vice versa. It has a very clear meaning, in other words. And it's also sensitive. So can we actually move it? Yearly active users would be very cool for Snapchat, but we can't really move that very easily in our product experimentation and so forth. So directionality and sensitivity are two very good principles for creating good metrics. So again, to measure phone speed, we should first think about the business. So first we should think about what are the business metrics that we actually care about that will help us frame how we want to measure phone speed, actually. So let's just think about the Snapchat core business metrics we care about. Engagement and revenue. Of course, engagement goes up, revenue goes up. It's a very indirect sort of revenue pipeline. These, of course, can include number of photos and videos per user, number of times you open the app, number of messages exchanged with friends, number of ads watched and clicked through, and so forth. Note that all of these business metrics are by user. So user level number of photos, user number of times you open the app, and so forth. Any questions so far, by the way, before I continue?
No, that's pretty clear.
Okay, great. So what we've done so far, we've thought about why do we care about mobile phone camera speed and what are our key business metrics. Let's now think about how we're going to measure phone speed. Okay, so how do we measure phone speed? How do we measure, the camera speed on your Snapchat app? Let's start off by thinking about how people measure speed historically, engineering latency in general. Okay, let's think about like Google.com, for example, just as an example. Every time someone comes to Google, you record how long it takes to load and to show them Google.com. That's a single latency observation measuring website speed. So, as many people continually use Google.com, you receive a huge ongoing stream of many, many, many speed observations. 2 seconds to load Google, 5 seconds to load Google, and so forth. You can obviously downsample if it's too big. The usual approach has been to take that giant stream and just take a single percentile over that. We just say, okay, what is the 50th percentile speed? So for example, if Google has a 50th percentile latency or speed of say 3 seconds, that means that 50% of all user requests can load Google in 3 seconds or faster. So that's how people historically have measured, say, engineering speed. Now, getting back, how do we think about like mobile camera speed? We could do this for Snapchat. We could just take the giant stream of requests to Snapchat and say, what's the 50th percentile, what's the 90th percentile, and so forth. However, there's a problem. Unlike Google.com, where when you send a request, Google processes it and gives it back to you. The Snapchat camera actually runs on your phone. So again, thinking like a product manager, it's important to realize that your camera speed, your phone camera speed depends on many different things. It depends on Wi-Fi and data and phone type and sort of where you are and all sorts of different things. In other words, phone camera speed is actually really depends on the user and where you are and all sorts of other things. So a simple way to measure camera speed is just to measure camera speed quantiles by user. Angie, for example, your 50th percentile speed is 2 seconds. So for example, we would say 50% of the time you specifically use Snapchat, you can load it in 2 seconds or less. Maybe my 50th percentile is slower and it's like 3 seconds and so forth. Anyway, so just tying it up all together in terms of measurements, we have user level engagement and business metrics we care about, right? Number of photos per user. And then we're going to have like user level phone speed as well. So we'll have like, say, 50th percentile phone speed per user. And that will allow us to say phone speed impacts user engagement at the user level in a very direct sort of manner. So that's how we should think about measuring phone speed. Gotcha. And there's more we can go into, of course. Yes, yeah. Quite a lot of stuff so far.
Yeah, definitely. So it seems like you're breaking down the measurements by different levels of aggregation, right?
Yeah.
So imagine this is a lot of different measurements to take. So how do you ensure that this data is high quality?
For sure. In general, like the mobile phone ecosystem is very, very large. It's obviously on the Apple side, you only have a few different iPhones. They're all generally quite good. But on the Android phones, you've got like 20,000 different phones across, all sorts of conditions, right? You've got like data in Africa, you've got like phones in South Asia, you've got phones in Eastern Europe and like South America, and obviously like the US and Europe and China. So it's important to realize that like the data quality and the phone speed measurements you're going to be getting, because again, Snapchat runs on your phone. Those phone speed measurements are not necessarily going to be nice and tidy and clean. Plus, people do weird things with their phones, right? Like what if people like start Snapchat up and want to take a photo, the camera freezes, but maybe like the timer keeps going. So you're going to get all sorts of, weird kind of things like that. So it's important to have a bunch of sort of checks and balances to think about, to make sure that, the phone speed measurements, the camera speed measurements you get coming in are very reliable. There's a couple ways we can think about this. We should obviously have some monitoring to make sure that, well, say the camera speed measurements that we're going in are actually coming in. There are engineering parts, right? Things that we can control. The Snapchat mechanism actually, works as intended. There are those sorts of things within our control. The Snapchat app works in recording these measurements and so forth that we can check and we can monitor. But there's also things out in the wild that we should monitor as well. So for example, like Wi-Fi speed and battery life and other diagnostics that can all impact phone speed are things that we should, make sure to keep an eye on as we're thinking about phone speed coming in. And well, phone camera speed, of course. To do this sort of stuff, we can go down, sort of more like exploration into data quality, but just bringing up some of the things, we want to monitor things that are within our control. So does Snapchat at work? And we also want to monitor things that like are not within our control, like Wi-Fi conditions and so forth. I'll just leave it there before we sort of, in the interest of time.
Okay, sure. Yeah. So it sounds like then that there's a huge amount of rigor that you can use in taking these measurements. Then, like, how would you consider the trade-off between having very rigorous measurement methodology versus, urgent business deadlines, for example?
Mhm. For sure, for sure. Yeah, so we're always to one thing to realize is that our measurement is never going to be perfect. We will always have like bad measurements coming in from across the globe and so forth.
Mhm.
But in absence of things that we can't control, like wars and famines and so forth, the good thing is that we can try to make sure that at least our data quality is like stable. We can try to fix as much as possible and reduce the intercept, right? But we can also can control the slope and make sure that like if we have say metrics for data quality, that our dashboard looks like a straight line. We can
Mhm.
do that as much as possible. And if those data quality things don't change over time in the framework of our experimentation, our product development, ideally ideally we would be able to we would be able to either do relative comparisons that like A/B tests, for example, that don't really that would be able to sort of cancel that out, or we could at least sort of have some kind of stable place to start from. But anyway, I think like in terms of trading off between business constraints and measurement, obviously measurement is very, very important.
Mhm.
I would say if we can get to a point of stability, that would be very, very helpful. But I also understand sometimes we just don't have the time and perfect resources and so forth to wait on product to sort of delay product deadlines and stuff like that. So
Mhm. Right.
yeah.
Okay. That makes a lot of sense. Okay, so you had actually already mentioned a little bit about A/B testing, right? So
Yeah.
now suppose that the Snap engineering team has developed a new camera loading feature that during their quality assurance testing,
Yeah.
they found that it sped up the phone camera by up to zero point 0.2 seconds. So how would you evaluate whether this new feature works for the users? And can you walk me through sort of
Mhm.
like the pros and cons and trade-offs that you would consider? And how would you then decide whether to
Right.
roll it out to users?
hmm Sure, sure. So the most popular method in general in product and sort of tech product development right now to evaluate the impact of a new feature is A/B testing. I'll just briefly walk through. Would you like me to sort of walk through what an A/B test looks like and sort of what the definition is and stuff like that? Would that be helpful, or should I sort of
Sure, just
get to the
a really
details?
quick summary would be good.
Okay, cool, cool. So basically, in a general A/B test setup, we first randomize our group of users, our group of experiment users, into treatment and control in order to make the two groups kind of identical on average. We randomize them. Second, we only release our feature to the treatment group.
Mhm.
So comparing the average treatments and the average control outcomes, because they're identical on average, because we randomize, allows us to see whether the feature is more effective in the treatment is more effective than the status quo. So that's the basic idea of the A/B test. Randomize two identical groups. You release the feature to one, then you can sort of see what the change is only from that feature. That's the basic idea. But now, what does this look like? There are actually many ways to implement this statistically. It's just a general approach, right? Just sort of compare versus contrast. There are many ways to implement this statistically. The most popular approach, of course, is just to implement this as a two-sample t-test. There's also sequential tests and factorial tests and many more. I won't get too much into the specific statistical details, but let's think about a little bit how we would generate how we'd create an A/B test to help engineering test their new, say, camera loading feature that appears to be faster. So, um, oh, before I get there, actually, let me just talk very briefly about the pros and cons of an A/B test. An A/B test gives you an unbiased estimate of the causal effect, assuming good randomization. So that's really helpful. But the con is that it is limited to the population and the time period you run it on. So I run an A/B test here, US college students. That may not generalize to like China elderly folks, for instance. Anyway, moving on. So let's design an A/B test to test out our new camera loading feature and whether it improves camera speed at the user level for the outcome metric of interest. There's a few considerations we'll need to sort out. So these are things we would want to sort out with the camera team and coordinate with their product managers and so forth. So the first thing is whether there are going to be network effects that we need to worry about. So for example, if I get a new camera loading feature, it makes my camera really, really fast. And then I start sending lots of photos. Is that actually going to affect you, for example, who hasn't gotten the feature yet? So that's something we need to think about in terms of how we design this A/B test. Is it going to be a cross-sectional thing, split into treatment and control and just track over time? Or is it going to be a sequential thing, treatment, control, and so forth? So that determines the format, the overall format of the A/B test. The second things are really kind of what are the specifics of the A/B test? Like what's the total percentage of the population we want to experiment on, the sample size, how long to run our A/B test for in order to get that much population. What is our statistical significance level, aka the threshold, which constitutes a genuine feature improvement. The statistical power to make sure that if we don't see anything in our A/B test you know how likely it is that there is actually something lurking, and of course some good practices like AA testing. Don't reuse experiment populations from previous versions of the same feature and so forth. There's also some after test analysis we'll need to do. We may have to worry about, say for instance, selection bias, where for instance I get the you and I say are in the treatment group, we have the camera loading feature available to us, but only I actually choose to use it. So that makes our treatment a little bit smaller than usual. And then last bit, we do want to emphasize accessibility because at Snapchat, we want to care about the full spectrum of users, right? Not just the average users. And so to do this, we probably want to examine some what we call heterogeneous effects, right? Say I have a really bad Android phone, you have a great iPhone. Maybe on average, it helps, the iPhone people, but maybe at the lower end of the spectrum, it's not as good for people with bad Androids like myself. So things to think about. Those would be the general considerations to run an A/B test to test a feature like this.
Right, that makes a lot of sense. Yeah, so I like that you brought up selection bias. So let's say you have the scenario then that you mentioned that, but maybe it doesn't actually speed up Android cameras by that much. And so Android users end up using Snapchat less, and now you have less data from Android users. What would you do if that happened to be the case? And how do you think you might be able to detect this in the first place?
For sure, for sure. So again, it depends on the nature of the selection bias. In this case, we're actually receiving less data from Android users. So imagine we have a population, right? We have a treatment and we have a control randomized. But in our treatment group, they have the new feature. It's harder to log data for Android, so Android users are dropping out. So that means that we end up with just say, more iPhone users in that group and people who can actually log data. It's like all the Android users have dropped out. So if we want to understand and still kind of salvage results from this A/B test, well, not salvage, but just to get results from this A/B test, then we should consider, okay, our real treatment within the treatment, our real treatment is like everyone else who actually has their data. So in the control group, we actually want to also examine those kinds of users. Right? We want to compare apples and apples. To do that, specifically, something like the Heckman correction or like propensity score matching are generally the most basic techniques you could potentially use to say, okay, you have this kind of subset of the treatment. What is the proper subset of control to compare to? Apples to apples. So that would be the general sort of way to go forward.
Gotcha. Okay, so then are you saying then that you would do something like comparing the iPhone users just to other iPhone users in their
Exactly.
control group?
Exactly.
Okay.
And it's important to realize that the result, because there's selection bias, right? You don't have any results from those Android users who dropped out in the treatment, right? You only have results for iPhone. So it's also important to clarify to your product managers and engineering team members that your final results are only valid for those iPhone users and for everyone else who actually, stayed in sort of after the selection bias has been accounted for. So that's important to realize.
Gotcha. That makes a lot of sense. Okay. What if for whatever reason though you can't actually randomize your groups? What would you do then?
Exactly. Well, then the other option, of course, is to do an observational study. That's a by definition we won't be able to randomize, and so we'll just have to do some historical analysis. This gets more into the econometric side of things. What we can do, for example, is say we can't randomize, but we can't randomize this new feature, for example. But say there was a similar historical feature or similar historical shock or historical event that randomly affected some users. Like, for example, maybe sort of just thinking off the top of my head, say, for example, there was an engineering bug that caused a very similar change that was similar, maybe caused some similar changes to users, but in a sort of randomly allocated sort of way, we could try to use that. That would be the instrumental variables method. If we can't randomize and we actually do release this feature to users, what we could do is do some kind of different kind of analysis where essentially we say, okay, treatment, they're not random, but they got the feature. So we have the control group, rest of the population. We assume the difference is sort of, similar in the absence of the new feature, but they got the new feature, and we sort of track the difference over time. So we could do a before and after kind of analysis with different diff or something similar. That is also an option as well.
Okay. So in observational studies, though, so you're saying that we compare before and after. How do you make sure that there's no confounding or looking variables there because of the difference in
Mhm,
time?
mhm. Exactly. Yeah. So again, these models have sort of different trade-offs and different assumptions. Because we're doing an observational study and we aren't able to randomize, we have to make some stronger assumptions than usual. So for example, if we were to use a different method or even synthetic control, which is like a very, which could be considered maybe a fancier version of different diff. If we were to do a different diff method, we have treatment and control before before we actually release our feature. We track them and say this is the difference we observe between treatment and control, because post hoc we actually know who got it, so we say okay, treatment with control, this is a difference. We assume that difference is constant, or at least after controlling for everything we can, it is constant over time. And so in the absence of the new feature, it would just continue to be constant. However, there's like a little lift when we release the feature, and so we would consider that to be the causal effect, assuming our assumptions are accurate.
Okay. Mhm.
Yes, exactly. So that would be, an example of the kind of assumptions that we want to make, and we would have to think about carefully and sort of deal with if we were to do an observational study.
Right. Okay. All right. Makes a lot of sense.
Mhm,
Thanks for going through
mhm,
that with me.
mhm.
Okay,
Yep,
so let's move
for
on to
sure.
the final part then. So now
All
you've
right.
done all this analysis, you've collected
Mhm,
data, you've
yes.
done A/B tests,
Mhm,
and
mhm,
you've decided with your PM, we're going to launch this feature. Okay, so
mhm,
now
mhm,
you've launched the feature, everything works well, the metrics look great. How would you then go on to actually present your results to your company's leadership? And
mhm,
how would you make sure that the feature continues to work well in the foreseeable future?
mhm. For sure. So let's tackle the first one first. How would you present our results to executive leadership? Um, Ideally, with the engineering teams, we want to have an ongoing dialogue with them to say, these are what we've tried, we've gotten all the feedback, kind of iron out all the stuff. So by the time it gets to the executive leadership and we're ready to present, we have sort of ironed out most of the details and we've done, all our sort of homework and all that good stuff. In terms of the format for executive leadership, obviously it depends on the company. However, there's a couple of good principles, I think, that one should do when presenting to executive leadership or in general, maybe non-technical, possibly non-technical stakeholders. The first is having a short slide deck with a summary at the beginning and a summary at the end, so that they know what are the key points, the key takeaways, what's a new feature, and sort of what did you do. We could of course talk with broad strokes, but they're not going to understand necessarily going to understand all the intricacies of our testing and statistical analysis and so forth. So in general, it's good to keep to just a few sort of things. Estimated business impact, ideally in dollars or even in known company metrics like daily active users. What are the potential risks and how would we mitigate it? Obviously, what would our launch plan be? Who will monitor it and safeguard the feature going forward? AKA, who are the points of contact? And maybe further reading to like a full doc or something like that. So some general principles, keeping it short, actionable, and very clear in terms of who owns, what parts of the feature and stuff like that. So that's in terms of presenting the results. In terms of monitoring, it's obviously very feature specific. The idea here is, of course, you want to make sure that our feature continues to work and we don't launch it and it's out in the wild and causing a ton of damage. In general, it's good to probably have some dashboards and monitoring for our feature. For camera speed specifically, again, this is very feature specific. We do want to, obviously track what is the camera speed, what are some of the metrics around that, like are we hurting people across the spectrum, right? What are different quantiles? Is it on, is the average looking good? Is kind of the long tail looking good as well? We do want to have some quantile metrics and dashboardings that are just to make sure that camera speed, our feature, is working as intended. There could be some engineering metrics as well related to engineering. We also want to track, some sort of like metrics that may also kind of indirectly be impacted, like battery life or say swipe speed or photo and video resolution, just to make sure that even if our feature itself is working good, it's not adversely impacting everything else. And then something that we also could consider, this isn't always possible, but something we can consider is having a long run holdout as well. So instead of releasing to everyone in the world, we release to most people in the world, but we still keep a lot of people like as the control group, as a group that doesn't receive the new feature. And so keeping this long run holdout group over time sort of will allow us to essentially A/B test this long after the feature has been officially released. So that's something to do. In terms of sort of business monitoring, it's important to know the points of contact, engineers, engineering managers, product managers, and so forth. Make sure they know how to read the dashboards, what the thresholds are, and sort of what to do if something goes wrong. And then lastly, the data is great, but it only gives you implicit signals. It doesn't tell you what users are thinking exactly. So it's important to work with product feedback and user research teams to understand what is some explicit user feedback and how are they actually enjoying and thinking about the features in text, in words, or in surveys. So those are some things to do that would be good for monitoring a new feature like this.
Yeah, that makes a lot of sense. Speaking of like the future outlook of this feature, can you foresee some ways of like being able to further scale it in the future or like extend it?
For sure. Well, again, it really depends on the nature of the engineering. Of course, maybe the engineering, for instance, can be like the basis for creating a similar platform for other speed improvements in the product. Maybe it's more of a self-contained kind of things. And so in terms of engineering impact, it probably depends on the feature itself. Phone speed may have implications for, say, I don't know, loading speed in other parts of the application and so forth. In terms of data science impact, publishing like methodologies, either with internal papers or conference papers or patents and those sorts of things can be very useful, just in general for sort of educating other people in the company, like how do you deal with selection bias? How do you do observational studies and so forth? And could be a good way to just build out good practices in data science at large.
Gotcha. Okay. Thanks so much for chatting with me today, Evan. You did fantastic. So I usually like to end these interviews with a little debrief section. So how do you think that went? What do you think went well? And what do you think you'd want to work on a little more?
Yeah, for sure. So let's see. I think that I think like overall, I tried to go through and give very broad strokes. So as you noticed, right, we didn't go into the very deep, specific statistical details or nuances of like Heckman corrections and stuff like that. So we're just going in very, very broad strokes. I did spend quite a bit of time in the business intuition and metrics at the beginning, talking about the intuition for why do we care about phone camera speed and how to think about good metrics and so forth. But if I were actually in an interview, depending on what else we talk about, and also depending on who the interviewer is, right? If they're a product manager, maybe they know a lot of this stuff already, or similarly a data scientist, it may be worth condensing that a little bit more. For example, if you're talking with another data scientist, maybe you don't need to talk about what are the guiding principles for good metrics and stuff as much. It may be helpful, but you may already be on the same pages for that. So that's something to consider.
Right. I actually really like that you included so much of the project context, though, because I think a lot of the rationale for this feature and why it matters then ended up informing which evaluation metrics you decided to choose, and also how you actually ended up measuring those things as well. And I also really like that you broke down the questions and gave answers for multiple aspects of the question. So not just the statistics side of it, but also the business logic side of it. And you gave really careful justifications for all of the decisions that you made.
Thank you. Another area actually that I think would be good actually to focus on, for next time, and actually may actually be quite of interest to data science decision makers, is the actual decision making, hands-on decision making when you get your A/B test results, right? How do you think about insignificance, or what happens when you have significance but a very small effect, or what if some metrics go up and some others go down and stuff like that? How do you think about that? How do you think about the thresholds in terms of 10% enough, 5% enough, 1% enough? That would actually be very good to get into as well, just the specifics of these sort of thresholds and decision making. But of course, just going in broad strokes.
Yeah, I agree. That sounds really interesting as well. Would have been useful to include. And another thing I was going to mention also is be able to explicitly state the assumptions that you're making, even if they might be obvious. If you have a thorough understanding of all statistical tests, I think it still helps in this scenario because it makes explicit the trade-offs that you're making.
That's a good point. Definitely.
All right. Thanks so much for joining us today, Evan. That was so great. And for those of you watching, good luck on your future interviews. Okay, bye, everyone.
Thank you.
Thanks so much for watching. Don't forget to hit the like and subscribe buttons below to let us know that this video is valuable for you. And of course, check out hundreds more videos just like this at tryexponent.com. Thanks for watching and good luck on your upcoming interview.